Today we will be looking at point slope form, which is yet another form that we can write a linear equation in. So we are going to review the two that we already know. We know that standard form from yesterday is ax plus by equals c. We can use that because it quickly gives us the x and y intercepts. We use slope-intercept form, which is y equals mx plus b. That one is a good one to use when you need your slope or your y-intercept. Today then, our point slope form is just the third form to write a linear equation. And that form is the following: y minus y sub p, and I'm going to put p, some books put 1 or 2 or different things like that, that's just a subscript, is equal to m times the quantity x minus x sub p. So if I look here and we want to talk about the meaning of the different variables, m, just like in slope-intercept form, is your slope. The x sub p and y p are a point on the line. And that is why I chose to use p, to remind you that that needs to be replaced by numbers that represent a point from the line. So if we look at our first example here, it says graph the equation y minus 5 is equal to 1/2 times the quantity x minus 2. Well, we need to remember the form. This is your y sub p, this is your slope, and this is your x sub p. Pay very close attention to these signs. These started out as negatives. So the negative there is only part of the formula. So I know my slope here is going to be 1/2. The point here, my x sub point, it looks like it's -2, but remember that negative sign is part of the original equation. So my x here is 2. The same thing with the y, that negative is part of the original equation. So my point is 0.25. We did this way back last year when we graphed using the slope and a point. You first graph your point of 2,5, and then we're going to use that slope of 1/2. Remember, it's y over x, so it tells you if it goes up or down, and then left or right. So I'm going to go up 1 to the right 2. There's my second point. I'm going to graph it by connecting it once again with a straight edge and placing arrows at the end of my line to signify it continues on in both directions. Example number 2 then is writing an equation in point slope form. We know our form is y minus y sub p is equal to m times the quantity x minus x sub p. So write an equation on a line that has a slope of -3, so that's my m, passes through the point -1, which would be my x sub p, and 7, which is my y sub p. So now I just replace those three parts with numbers, and I will be done. So I get y minus y sub p, which is 7, is equal to slope, -3, times the quantity x minus, and it's -1, a -1. We do not want to leave two signs side by side, so we simplify. So my final answer here would be y minus 7 is equal to -3 times the quantity x minus a -1 is x plus 1. So that would be the simplified answer, and that would be the correct answer there. Okay, example 3 then. wants you to use 2 points to write the equation of the line. It says write equations for the line in point-slope form and in slope-intercept form. Point-slope form, you need 1 point. I'm going to pick the point 2, 3. As long as a point is on the line, it doesn't make a difference what point you use. Then I need to find the slope. Well, to find slope, I count the difference in the y over the difference in the x. 1, 2, 3, 4, 5, 6, 7, 8 up, so it's a positive 8. 1, 2, 3 to the right, so it's a positive 3. So my slope is 8 over 3. So my point slope form is y minus 3 is equal to 8/3 times the quantity x minus 2. Remember, there are more than one option for this answer. So if I were to write the second option, just so that we can see it this time, you are only expected to write 1. I could have chosen to use the point -1, -5. My slope, because it's right here on the line, my slope is still 8/3. So I could have said y minus a -5 would be y plus 5 is equal to 8/3 times the quantity x minus a -1 would be plus 1. So I could give either of those two answers and be correct. Slope-intercept form, then, I need to find my m and I need to find the b. Well, we don't have to do that in this case because we could pick either one of these and rewrite it, which would be the faster method. So that's what I'm going to do. I'm going to pick this first one and I'm just going to rewrite it. Y minus 3 is equal to 8/3. I'm multiplying to distribute x minus 16/3. There we go. To get it in slope-intercept form, I have to get y by itself. The opposite of minus 3 is to add 3. So y would be equal to 8/3 x, and it's minus 16/3 is the same as 5 1/3, so 5 1/3 plus 3 would give you a -2 1/3. Y equals mx plus b. There we go. If you look, your slope matches up with the slope we found here. If I look at the graph, does it look like this might cross at -2 1/3? Yeah, it looks a little bit lower than 2, so it makes sense with our graph. Example number 4, then, is writing an equation using a table. Pay attention carefully to this definition of linear relationship. Two sets of data have a linear relationship if the rate of change, which is another way to say slope, between consecutive pairs of data is the same. So it wants to know, in this table, is the relationship shown by the data linear? If so, write an equation. Well, in order to see if it's linear, I have to compare the slopes. So I need to find the difference in the x's each time and difference in the y's each time. The difference in the x's, -1 to 3 is plus 4. 3 to 5 is plus 2. 5 to 11 is plus 6. 4 to 6 is plus 2. 6 to 7 is plus 1. And 7 to 10 is plus 3. Then to compare them, remember the slope is y over x. So the difference in the y, 2 over 4, that one reduces to 1/2. Is that equal to 1 over 2? Yes, it is. Those are the same. Then I check the third one here, y over x, 3 over 6. That also reduces to 1/2. So is the relationship shown by the data linear? Yes, it's linear. And write the equation. It does not tell you what form to write the equation in, So anytime it does not tell you, I would go ahead and put it in y equals mx plus b form, or whichever one is quickest. If I look here, I know the slope of 1/2. I don't have my b over here, but I have several points. So I have a point, and I have the slope. The fastest way to write it then is using point-slope form. So that's the good thing about knowing 3 forms. You know which one that's fastest to write it in. Point-slope form is y minus, I'm using this point, so 4, is equal to my slope of 1/2 times the quantity, x minus -1, so x plus 1. There we go. So if it does not tell you what form to write your equation in, you can write it in whatever form is the fastest or easiest for you, now that we know all 3 of them. Example number 5 is our real-world problem solving again. It says, is the relationship shown by the data linear? If
Sean
so,
Pyatt and Laylee Norton, your ride is waiting.
model.
Sean Pyatt and Laylee Norton, your ride is waiting.
Go ahead and model it with an equation. The difference from 8 to 4.5 is minus 3.5. From 4.5 to 3 is minus 1.5. And from 3 to 2.5 is minus 1/2. The y's over here, the difference is 6.3, 2.7, and 0.9. Now I compare them. Y over x, that reduced to negative 1.8 for me. 2.7 over the x of negative 1.5 also reduced to negative 1.8. Remember, to be linear, all of them have to reduce the same, so you will need to check all of them. 0.9 over negative 0.5 also gives me negative 1.8. Since all these slopes reduce to the same, it is linear. Again, I have the slope. I have several points. This time I'm going to pick this point. There's no reason. I could pick any of the 4 points, and I have a point, I have slope. The fastest way would be slope-intercept form. Y minus my y, which is 206.6, is equal to the slope, negative 1.8, times the quantity, x, minus the x value of 3. And that could be my equation of the line. Because again, it did not tell you what format to put it in. Go ahead and check your schedule to see what your assignment is to go with this lesson.